With this pendulum with a large angle, we would like to explain how the inertial force works. An important property of inertia is that in order to change the speed of a moving body, a force greater than the inertial force of the body is required. So a force that is not greater than the inertial force of the body cannot change the speed of the body, neither accelerating nor decelerating it. If the pendulum is released at point A, it is accelerated downwards in a tangential direction due to the force of gravity. The magnitude of this driving force is as follows. It is maximum at point A and zero at point C. And the pendulum has an inertial force as follows. It is zero at point A because its speed is zero at this point. And it increases with increasing speed. There is then a point at which the inertial force F balances out with the driving force F. This point is assumed to be point B. After point B, the driving force F is smaller than the inertia force. Therefore, the pendulum cannot be accelerated any further and its speed remains constant up to point C. If the pendulum continues to move upwards from point C, the driving force acts against the movement of the pendulum. Because F is smaller than the inertial force of the pendulum at the beginning, the speed of the pendulum cannot decrease until point D, at which point the driving force balances the inertial force again. Above point D, F is again greater than the inertia, and then the speed of the pendulum is slowed down. The speed of the pendulum from point B to point D is therefore constant. It is also the maximum speed of the pendulum during the entire movement. It is clearly not equal to the maximum speed that results at point C from the law of conservation of energy. All moving objects, including the motion of the Moon around the Earth and the planets around the Sun, obey these rules. We have every reason to doubt the correctness of Kepler's laws, which represent a planetary orbit derived solely from mathematical equations without understanding this rule of motion. In this context, we would like to emphasize, mathematics can only describe physics, not replace or create it. See link below for a detailed explanation.